Hi Math 3 students. Today we are going to be going over how to find x-intercepts and y-intercepts of rational functions. Now if we look, you can go back to that little cheat sheet that I gave you. We are, just so you guys know, we're skipping the horizontal asymptote stuff for right now, and we're scooting on down ahead here to finding x-intercepts and y-intercepts. Okay, so it's on your blue sheet. So x-intercepts, if we look, it says to find x-intercepts, you set the top equal to 0. Now, one thing I want to emphasize is for everything, after you find the holes, or actually, I guess I should say, for x-intercepts, y-intercepts, vertical asymptotes, you have to first double check that that thing's not a hole. So basically, you're going to factor, simplify if you can. If it cancels out and it's a hole, it can't be an x-intercept, can't be a y-intercept, can't be a vertical asymptote. All right, so keep that in mind. All right, so let's go back to this example we had here. On our example, these guys canceled, right? So after we simplified, we were left with x minus 4 all over 2x plus 7. If you recall, that was just from this problem here, okay? That was our simplified version of the rational. So how you find x-intercepts? Well, x-intercepts occur when your y value is 0. Okay, and in this case, we're only going to get 0 when we have a 0 on top. It's going to be like 0 divided by some number, okay? As long as it's not 0 divided by 0, which we've already rolled out by, or actually, no, I take that back. We've rolled out the whole in that case. But if you do 0 divided by some number other than 0, that's going to be a x-intercept, all right? Because you get an x-intercept when it is some value of x and your output is 0. All right. So we find this by taking our numerator, setting it equal to 0 and solving. Okay. So when we do that, we get that x equals 4. So our x-intercept in this case is just going to be 4, 0. All right. That's it. That means that the function's going to go through the point 4, 0. Now, y-intercept works similarly. Again, we're going to use our simplified version here. All right. And we are going to plug in 0 for x. All right. Now, excuse me. If you previously decided that x equals 0 is undefined, it's no use, right? Or no good. It can't be a y-intercept, okay? So if it's undefined as a whole or undefined as an asymptote, that means there's no y-intercept there. In this case, our undefined values were 1 and -7/2, so we're good. So we can use an x value of 0, and we're going to go plug that in. So you get 0 minus 4 all over 2 times 0 plus 7. So we end up with -4 all over 7. So our x-intercept is -4/7. So it'd be 0, -4/7. Okay, so keep this in mind as kind of keep your blue sheet out as we are going through these examples, so you can remember what you have to do for each thing. Okay, so of course I lost where I was. All right. All right, so we're going to go and look at where our x-intercepts are at, which happens here. All right. So first thing we're going to do is factor the heck out of everything. All right. So this top part here, I can take a 2 out first. So I'm going to take a 2 out, and let's see, 162 divided by 2 gives me 81. So I actually can factor that further, and I get 2, x plus 9, x minus 9, because that is a difference of squares. On the bottom here, I can take out an x value because that's a GCF. And I get x times x plus 9. All right. Now, you're going to want to simplify. All right. Once something is a whole, it cannot be an x-intercept. All right. So we cancel that out. And we are left with 2 times x minus 9 all over x. All right. At this point, once we've simplified as much as we can, we're going to go ahead and set the top equal to 0, because if you look at your blue sheet, that's how you find your x-intercepts. Now, you Can't make 2 equal to 0, right? If it was a 2x, you could, but a 2 you can't do anything with. But we can make this equal to 0, and we get that x equals 9. So we are going to have an x-intercept at 9, comma 0. All right. Here, let's try the next one. So the first thing we got to do is factor everything. So the top part here, I don't see a GCF, so I just got to do my multiply-add method of factoring. So I'm going to go ahead and I get x minus 7 and x plus 4. Now, unfortunately, this next guy, we got to do AC factoring. So I'm going to go ahead and do that. I got to multiply to negative 20 and add to negative 1. So my two magic numbers are going to be a minus 5 and a positive 4. So I'm going to do 2x squared minus 5x plus 4x minus 10. We can take an x out and we get 2x minus 5. We can take a 2 out and we get 2x minus 5. So the fully factored version of this is going to be x plus 2 and 2x minus 5. Now, in this case, nothing cancels, right? There's no holes. So this is our simplified version, because we can't simplify it. So you're just going to, again, we're trying to find the x-intercepts. Just take this top, set it equal to 0. So x minus 7, x plus 4, if I asked you to solve that, x minus 7 equals 0, x plus 4 equals 0. You get 7, and you get negative 4. So we have an x-intercept at 7, and we have an x-intercept at negative 4. Oops. And one thing I want to, I probably should have pointed out here, if it's an undefined value, it also cannot be an x-intercept. So like x cannot be equal to, well, let me think, actually, it would have canceled out with something on top anyway. So you know what? I take that back. Don't worry about that. Anywho, set those equal. So really the only thing for x-intercepts that you have to look out for is holes. All right, so that's why we got to simplify first. All right, next one here. At the top, I can take a 3 out, so I'm going to get x minus 8. And honestly, at this point, if you think you can do one of these on your own, I would pause the video and just give this a shot and see if you can do it. X minus 10, x plus 4, nothing cancels. So I, again, just set the top equal to 0. X minus 8, x equals 8. So our x-intercept is going to be 8, comma 0. All right. Let's go ahead and try a couple of the y-intercept ones real quick. So again, if you look at your blue sheet, you get the y-intercept by, and actually, here's the deal, is the x-intercept you have to simplify. The y-intercept, you could either use the simplified version or you could literally just go plug in. Because if you have an undefined value, essentially what's going to happen is you're going to end up dividing by 0 and you'll be like, oop, it doesn't work. Which actually we might find that out right here. So to find the y-intercept, you plug in 0 for x, right? So if we did that, we do 0 squared minus 100 all over 6 times 0 squared minus 15 times 0. So we get negative 100 on top. And on the bottom, we actually get 0. So this is undefined, which, if you think about it, right, we actually do have, we're going to have a vertical asymptote at x equals 0 when you go ahead and plug that in. So that makes sense that we can't have 0 comma something, which would be our y-intercept, because it's undefined there. So this one is, we don't have any. All right, because our y-intercept there is undefined. All right. All right. So let's try this guy. All right. So actually, I guess now that I think of it, it would probably make most sense to plug into the unsimplified version for the y-intercept now that I think of it. But anywho, 0 squared plus 3 times 0 minus 27. 3 times 0 minus 9. Oops. All right. So we're just plugging 0 in. We end up with a minus 27 all over minus 9. We're going to do 0, comma, and we end up with 3. All right, so we have a y-intercept at 3. You cannot have more than one y-intercept. You're going to have none, you're going to have 1. If you have more than one, it is not a function. All right, so y-intercept, we're going to plug in 0 for x. So 2 times 0 squared minus 14 times 0, all over 4 times 0 squared minus 81. So when you plug this into your calculator, you end up with 0 over negative 81, which gives you 0. So you have a y-intercept of 0. All right, last one. Definitely this one. See if you can figure it out on your own. I'm going to go ahead and do it, but pause the video. See if you can find the y-intercept. So we're going to go ahead, plug in 0 for x. And you'll see we end up with 18 over negative 18. So we have a y-intercept at 0, negative 1.